Hi, my name is Matt, and in this video, I'll be highlighting some of the changes that we've made in patch 1.5.4. Okay, in patch 1.5.4, we've modified the database to support 40 automatic mode test points. This is up from the 20 previous. We've added phase data measurements and the ability to export phase data. A table view has been added to the automatic mode test in addition to the graph. The table view shows phase data and deviation from the reference. New RMS options for shake and sensitivity modes have been added, plus much more. See the notes for a full list of changes, and in the comments below we'll list the changes as well. For the first demonstration, I'll be showing the RMS changes. To do so, I'll be using the A-4404 signal analyzer box, and I have this connected to the Dytran reference accelerometer, and we'll go ahead and shake it in 0 to peak. And I'll go ahead and start the shaker and start the analyzer. So the shaker says that we're shaking at 0.99 and it's adjusting to 1G. Let's see, okay, so it's now the shaker says it's adjusting to 1G, and the analyzer says that we are reading in 0.703 RMS and 0.993 Gs 0 to peak. So what if we want to measure 1G RMS? So now we will go back to the setup menu, to unit configuration, and we will check the newly added vibration unit box, change this to RMS. Now we can go back to shake and go ahead and hit start. And we will see that the top window here is now shaking in 1G RMS, and the bottom window in 0 to peak will be shaking at about 1.41 Gs. So now the shaker is starting to settle. See here, the 1G. And there you go. So you can see that the shaker is now shaking in RMS, 1G RMS. And it's also noted up here in the shake screen now on the shaker says target vibration in RMS. Now, if you wanted to do that in the sensitivity mode, what you would do is you would go to the sensor setup program, and you would check the box here, RMS, for RMS units in the sensor setup program. While I'm here in the sensor setup program, some of the things we've added into the sensor setup program is you can now import your own image. So you would click this box here and then select what file you wanted to import into the sensor for a picture of the sensor when you're scrolling through the library. And you can now add up to 40 test points in this box here. These are automatic test points that the shaker will sweep through. Back to the automatic test. We'll run the automatic test for a IEPE by Dytran. This is the 3010 M112. And then I'll click automatic. And you can see now we've added a table view. And this is in addition to the graph. If you still want to see the graph, you would select on screen or press down the right frequency knob. The shaker takes an initial measurement at reference frequency, and then it'll plot the deviation on the graph based off of the reference frequency. It does the same thing on the table mode, except it's not plotting data on a graph. It's showing you the actual deviation in percentage. So here we can see that the reference sensitivity was 9.8, and the second measurement at 500 Hertz was 10, and this is a 1.7% deviation from reference frequency. And this is the way that you would calibrate a sensor, is to take the deviation based off of the reference frequency. The reference frequency doesn't have to be 100 hertz. It can be whatever you want it to be. It's typically based on your location. It does change based on the frequency of your wall power. So if you wanted to adjust the test reference frequency, you would do so here in the sensor setup program. Okay, I'm going to go ahead and fast forward to the end so you could see the end result. Okay, the data is saved, so let's go ahead and export it. I'm going to put it in my USB stick. Then I will go back. Save the PDF to the USB stick. And now I can show you the new formatting of the calibration certificate. The calibration certificate now holds up to 40 automatic test points. The calibration certificate is fully customizable, and this is auto-populated by the shaker. So the shaker is going to tell you what the reference sensitivity was. It'll list the reference frequency right here, all the sensitivities it took, and then the deviation relative to the reference sensitivity right here. So this is probably one of the numbers that you care the most about when you are past failing a sensor. This is the deviation relative to the reference, which is 9.79. All right, thank you for watching my video, and I look forward to bringing you more in the future.